So in this question, 8 people are to be seated on 10 seats around a round table. So that means there will be 2 empty seats. And we are going to assume in this question that all the seats are identical. That means you can't tell one seat apart from another. As well, you also cannot tell the position around the round table. It means among the 8 people, there are 2 couples. Mary and her husband is one couple, and Jane and her husband is another couple. So, and they would like to sit with their spouse. That means the couples would like to sit together. However, couple 1 is to be separated from couple 2. That means one possibility is like Mary and her husband, and Jane and her husband. But then there will be people in between them, so that they will not. These 2 couples will not be sitting together. They will be separated. But the couples, they will be sitting together with their spouse. So how many ways to arrange the 8 people on the 10 seats if the seats are all identical? Given those above conditions, how many ways can we arrange the 8 people on the 10 seats if the seats are all identical? So, right, there's a problem with round table that is different from a row. So for example, if I'm sitting like 3 people in a row, these seats are identical, are non-identical, because we can distinguish from the leftmost to the rightmost, right? So let's say there are 3 people, we can sit them as they are all together 3 factorial, because the first person A can sit on 3 seats, right? And the person B, once the person A has taken the 1 seat, the person B has 2 seats to choose from. So any of the 2 seats, and the last person has only 1 seat to choose from. So it's 3 factorial, which is equals to 3 times 2 times 1 way. Altogether 6 ways to arrange the people, and you can see it from here: A, B, C, B, A, C, and B, C, A, and then we have A, C, B, and we have C, A, B, and C, B, A. So altogether 6 ways, right? We can see in the case of a row. However, when these 3 people are seated in 3 seats on a round table, then there is only 3 factorial divided by 3 ways, because the seats are identical and you can't tell them apart. So there are a few ways to think about this. There are only so A, B, C is one way, and A, B, C is another way. Okay, any other ways will look like these 2 ways, because let's say if I choose one like A, B, C, this is actually the same as this case, because if we go and rotate because the people cannot tell their orientation in the room, right? That's the assumption for this type of questions. They cannot tell their orientation. So let's say if for example, if it's on C will think that he's to the left of A, and B will think that he's to the right of A. Similarly, in this case we have here, C will think that he is to the okay, so this one, for this case, the C will think that okay, A is sitting here, so C is on the right of A, sorry. So C will think that he's on the right side of A, and B will think that he's on the left side of A. So in this case, is the same. C will think that he's to the right of A, and B will think that he's to the left side of A. Correct? So then it will be these 2 cases will be considered the same. Only when in this case, the A will think that he's to the B will think that he's to the right of A, and C will think that he's to the left of A. So this case is different from these 2 cases. So the 6 cases will reduce to just 2 cases when seated on the round table. So that's generally the approach. So in order to and then another type of thinking perception way to think about this kind of like the round table questions is you can let's say, okay, there's although these 3 seats are not identical, and you cannot tell them apart, so you can sit any one of the 3 people here. So for example, by sitting A here, then I'm left with B and C to arrange, right? By sitting A here, and then it doesn't matter which seat A chooses, because they are all the same. So you can't tell them apart. So seating A is just one way, all right? And then now by seating A, now we can distinguish this seat from this seat, because the A serves as the marker. People can tell themselves apart. We can tell that the two seats apart now by taking the orientation from A. That means we know that, okay, this seat is to the right of A and this seat is to the left of A. So they are no longer identical. So to arrange them, I just put 1 times, now 2 person on 2 non-identical seats, we put as 2 factorial, so you will arrive at the same result as the earlier method. So in that case, right, what I'm going to do is, for this question, the first thing I do for the round table is to choose one person that is not one of the couples to sit on one of the seats. So that person, maybe there are 8 people, right? 8 people, and couple 1, which is like 2 people, and couple 2, another 2 people. So there will be another 4 people left. Out of these 4 people, I choose one to sit on any of the seats, and that is constitute the one way, because whether sitting on any of these 10 seats, right, you will not be able to tell the difference. So it's only considered one way. Let's say if the seats are labeled, then there are actually 10 ways. But the seats are not labeled and are identical, so there's only one way, because you can't tell one arrangement apart from another, right? Even if you sit here or sit here, you can't tell this arrangement apart from the other arrangement, because the seats are identical and the orientation is not clear. That's the assumption. So then the next thing that we want to do, right, is we want to arrange the couple. So couple 1, I will arrange 2 factorial, because it's possible for Mary to sit on the right hand side of her husband, or Mary to sit on the left hand side of her husband, right? Then okay, so these are 2 ways, so 2 factorial, and then note 2 factorial is just 2 because it is 2 times 1, right? 3 factorial is 3 times 2 times 1, and so on and so forth. So 4 factorial will be in case 4 times 3 times 2 times 1, in case you are not familiar with what factorial means. So 2 factorial is this one. So we are going to arrange, this is the reason for this 2 factorial. And then we are arrange the other couple, which is another 2 people, the Jane and her husband, side by side. So there are 2 ways. So I will do another 2 factorial. Because these all things are happening together, so I use the multiplication principle. Right, it's just like if you have if you are going to throw a die, die 1 and dice 2, alright, the total outcomes would be 6 times 6, 36, right? So you will multiply them, there will be 36 outcomes. So in this case, the same thing is happening, because there are 2 arrangements for Mary and her husband, and 2 arrangements for Jane and her husband. So all together, they constitute 4 possibilities, right? 4 possibilities, because yeah. So then another thing is, after that, I'll need to arrange what we call the separators. Okay, so after I have after I have arranged the two couples as we consider them as a 1 unit. It means they will be sitting together anyway. So we consider them as like this is 1 unit and this is 1 unit, so that this is considered 2 units. And another 4 units of people and 2 empty seats. Alright, so to understand this question, you further have to understand the separator method. Later I will do some explanation in another video or this video at the very end. So right, there will be in order to separate the 2 couples, because the 2 couples cannot be seated together. So I will arrange the 4 people and the 2 empty seats around the round table. So that will be okay. So since I have arranged this one, I have marked out this seat with this 1 person, so it will be, the number of people will be 3 people here. There will be 3 people here. There will be 3 people here, right? And then the 1 person is used as the marker. Right, so then the 3 people together with the 2 people would be 5 people, or will be 5 objects. So I'm using the 5 objects as the separator. So 5 objects as the separator, I do 5 factorial, because the 2 empty seats are identical, so I divided by 2 factorial. For the concept for arrangement of identical objects is that you must divide the number of identical objects. So the number of separators altogether is 5, not including the marker as the 1 person. And then after that means the number of slots, if there are 5 people, then 5 people as the separators, the number of slots will be 1 more than the number of separators, which is 6. And so we choose 2 times 2 factorial. I think it's a bit challenging to explain this part if I don't go to the concept of the separator method first. So I explain the separator method. Okay, so for the separator method, let's say for example, there are 5 people called A, B, C, D, E, and B is to be separated from D. So I will arrange the rest of the 3. So I will arrange A, C, and E, which is 3 factorial ways of arranging them, right? Altogether 6 ways of arranging them. After I arrange them, right, there are 1, 2, 3, 4 choices of where I should sit B and D. Because if I sit them and only any of these are 4 seats, and they will be separated by the A, C, and E in between them. So out of these 4 possible slots, I'm going to choose 2 slots because I'm only sitting 2 people, B and D. So I'm choosing 2 slots to put the B and D, and then I'm going to arrange them because it could be BD, for example, or DB, right? So I'm going to choose 2 times 2 factorial. Right, so that is the separator method for arranging. For let's say if you need to arrange, so in this way. So let's say if I give another question, just three people. So B, C, and D. So I need B and D to be separated. Obviously, we know that there's only 2 ways to do this. Right, so applying the separator method, that means I will go and arrange the separator first, which is 1 way to arrange only because I'm just arranging 1 person, right? So 1 factorial. Okay, so then after that, after I arrange there will be 2 slots to sit B or D, right? So these 2 slots, I'm going to choose 2. I need to choose both because I'm going to sit 2 person, right? Out of these 2, so I need to choose both, and then I'm going to arrange them because it could be BD or DB. 2 choose 2 is just 1. This 1 factorial is just 1, and 2 factorial is 2. That explains why there will be 2 arrangements, right? So these methods, I'm showing you that it works on a small scale. So then, and of course it works on the big scale as well. So then in this case, after I arrange the back to this question, after I arrange the couple 1 and the couple 2, and I'm going to arrange the 5 separators. So 5 factorial because the 3 people and 2 empty seats. The 4th person, the fourth person, okay, is already used as the marker, so I cannot use them as part of the separators anymore. But because there are 2 empty seats are identical, so I divided by 2 factorial. So because I have 5 separators over here, if I have 5 separators over here, I have 6 slots to sit the 2 couples. Like, okay, why in this case it's like 2 couples? Because, like, for example, like if I arrange the 5 separators, right, around the round table, this is the marker. Okay, I'm just laying it flat here. So I can choose to sit the couple any of the 6 slots. I choose 2 slots because there are 2 couples. So couple Mary and her husband, and Jane and her husband may choose these 2 slots. So 4, 7, 6 choose 2. or we may choose another 2 slots. So how many ways to choose 2 slots? There are altogether 6. Choose 2 ways to choose 2 slots, right? And if we do this, we will have, then after that we need to arrange them 2 factorial, because it could be, so if for example you have chosen these 2 slots and there's still 2 choices over how you can see them, can be this or this way, so that's what that constitute 2 ways, so 2 factorial. So therefore that's why I am doing this 6 choose 2 times 2 factorial over here, right? So that will be the total number of ways to sit given this requirement, right? Okay, if you still have any question, you can ask me on WhatsApp. Okay, thank you.